This video will show you how to solve a 2x2 augmented system, a 2x2 system of equations using an augmented matrix. First, I'm going to take this system and write the augmented matrix for it, which will be 2, -7, 3, and 5, 1, 1, drawing that line, separate the two sides of the equal sign. My first thing is I'm going to need to put a pivot where that 2 is. I need that to be a 1. So what I'm going to do is multiply the first row by 1/2, and that's going to be my new row 1. And so when I do that, that's going to create 1, -7 halves, 3 halves for the first row, and the second row is still 5, 1, 1. Now I'm going to use this pivot at the 1 to clear out the 5 that you see here at the start of the second row. So I'm going to take -5 times my current row 1 and add row 2. Oops, I'm writing that in the wrong place, so let's get rid of that. I'm going to take -5 times my current row 1, add row 2, and that's going to become my new row 2. And I'll do a little bit of scratch work over to the side here. So -5 times the first row 1 will make that -5 plus 35 halves and -15 halves. And my current row 2 is 5, 1, 1. And so I'm just going to add those. And that's going to give me 0. 1 plus 35 halves gives me 37 halves. And 1 plus -15 halves gives me -13 halves. And so my system now represents 1, -7 halves, 3 halves. And the second row is now 0, 37 halves, -13 halves. With again that vertical line. What I need to do now is take that position, and that's going to become my new pivot where I've drawn this arrow. And so I need that to be the number 1. So to make that happen, I am going to take 2/37ths, the reciprocal of 37 halves, multiply it by row 2. That'll be my new row 2. So now my system becomes 1, -7 halves, 3 halves, and then the next row becomes 0, 1, and I'm going to use my calculator to do this. No, I don't need my calculator for this. -13 halves times 2/37ths just becomes -13 37ths. And so now I've got this, and now I can use that as my pivot. I'm going to use this pivot to clear the -7 halves away that you see there on that next row. And so that means I'm going to have +7 halves. Oops, that's hard to read. I'm going to have +7 halves times row 2. I'm going to add that to my current row 1, and that'll be my new row 1. And my row 2 stays exactly the same, 0, 1, -13 37ths. And to get my new row 1, I'm going to take 7 halves times row 2. So 7 halves times row 2 would be 0, 7 halves. And then I'm going to use my calculator, -13 37ths times 7 halves. And that gives me the fraction, -91 74ths. And then I've got 1 for row 1. I had 1, -7 halves, 3 halves. I guess I don't need the full matrix there, so let me erase this. There we go. And so let's add those. So I'm going to get 1, 0. That's the 1, 0 so far. And now I need, in that position, 3 halves minus 91 74ths, which I'm going to do on my calculator. And so as I'm punching this in my calculator, I get the fraction 10/37. So this system of equations is now telling me that x equals 10/37 and that y equals negative 13/37. And this would be my solution to the system. If I double check that and put that back into the original system of equations, there's the original system. Let's check that out. Do I have, if I have 2 times 10/37 minus 7 times negative 13/37, does that in fact equal 3? Well, I'm going to let my calculator do all the heavy lifting on this. So 2 times 10/37 minus 7 times negative 13/37. And yep, that sure is 3. If I check the second equation, 5 times 10/37 plus negative 13/37. Again, now I want to know, does that actually equal 1? And so I'll punch that in my calculator, 5 times 10/37 minus 13/37. And my calculator is telling me, yep, that equals 1. So that's my answer. Checked out.